Here we have a combination of a series and parallel connection, and we are asked to find the equivalent resistance of the circuit. The approach to this problem is that we simplify the circuit first. First we combine resistors 2A and 3 which are in a parallel connection, and we get its resistance is 2 ohms as shown in equation A. For current at the combined resistor 2 and 3 we use equation 6 and we get a function in equation B. For the voltage we use equation 7 and we see that it is just equal voltages as a condition for parallel circuits as shown in equation C. We further simplify the circuit into its fundamental form as shown in the image here. We now apply series equations for this phase. So for the total or equivalent resistor we have equation 1 and its total or equivalent resistance of the circuit is 6 ohms. We can further determine the parameters in the circuit starting with the equivalent current, which is done by using Ohm's law, and we get that it is 3 amperes as shown in equation D. We can also determine the value of the current at the combined resistor 2 and 3, which is just the current in series connection, so we use equation 2. And it is about 3 amperes as shown in equation A. The voltage at resistor 1 is done by using Ohm's law and it is 12 volts as shown in equation F. We can also determine the voltage at the combined resistor 2 and 3 by using Ohm's law. We see that it is 6 volts as shown in equation G. We now determine the voltage at resistors 2 and 3 separately, and we apply a parallel connection equation and we see that it is given in equation 7. The value would be just the same and it is 6 volts for both resistors. For the current we use Ohm's law to determine individually the currents, and for resistor 2 it is 1 ampere and for resistor 2 it is 2 amperes as shown in equations I and J. Here we have the complete image of the circuit with the given values. As the current flows first at resistor 1, the resistor takes up 12 volts, reducing the 18 volts by 6 volts, and we see that the parallel circuit part does consume the remaining voltage difference.